Math 1332, Chapter 2, Set Theory, Section 2.2, Subsets and Set Operations, Video 2, Venn Diagrams. In the previous video, we defined what a universal set was. In this video, we're going to show how to sketch a picture of a universal set and some of the sets and elements contained within it. Such a picture is called a Venn diagram. A Venn diagram is an illustration showing the relationship between a universal set, one or more sets in that universe, and perhaps individual, it would help if I spelled individual correct, and perhaps individual elements in that universe. The universal set is usually represented with a rectangle. Sets within the universe are usually represented with circles. You've probably seen Venn diagrams before. We're going to sketch a couple. The first example involves a universe and one set within it. The second involves a universe and two sets within it. For the first example, suppose the universe is the set containing 1, 2, 3, all the way up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to let set A contain some of the elements of that universe. In this case, set A contains the numbers 1, 2, 4, and 8. Then we'll sketch a Venn diagram. To start with a Venn diagram, you start with a rectangle. You usually want to make it fairly long to hold some circles and or individual elements. To indicate that this is the universe, it's standard to put a capital U outside of it. Remember, I make my capital U's look like horseshoes with the lines on top. That's to distinguish it from another symbol we will see later in this video series. For the actual set, set A, we can represent that inside of the universe, inside of the rectangle, with a circle. It doesn't matter where you put it. We'll put it here. And to indicate that that's set A, we just write a capital A right outside of it somewhere. Close enough so you know that that letter is associated with that circle. As far as the individual elements, representing an element in a set in a Venn diagram is simple. If the element is in the set, write it inside that circle. Otherwise, don't. For example, the first number in set A is 1, first element. Therefore, inside of circle A, we need to put the number 1 somewhere. That place is as good as any. In fact, we need to find a place for every element in the universe. So let's just go through them. We've already placed the number 1 inside of circle A because it belongs to set A. What about the element 2? Is that in set A? It is. Which means we have to write the 2 inside of here somewhere. And again, it doesn't matter where. But what about the element 3? That's in the universe. But notice it's not in set A, which means visually we don't want to draw the 3 inside the circle. We need to draw it outside the circle. Again, it doesn't matter where, but it's still in the universe, which means it has to be in the rectangle, but outside the circle. We'll just put it out there. And one at a time, we can just put every element where it belongs. Next element is 4, which is in set A, so it belongs in circle A somewhere. The next elements in the universe are 5, 6, and 7, none of which belong to set A. So none of 5, 6, or 7 go inside of the circle, which means they just go outside the circle wherever you want to put them. You can be more organized and put them in an increasing order, but it doesn't matter. As long as they are positionally correct, relative to the set and the universe, that's all that matters. Where were we? Oh, 8. 8, the greatest number in set A, belongs in circle A, which means the rest of the numbers in the universe, 9 and 10, belong outside of A but inside the universe. 9, and we'll put 10 down here. Drawing a Venn diagram with one set is easy. Rectangle with one circle inside of it. And if you're going to draw all the elements, if it belongs to the set, put the element in the circle. Otherwise, put it outside the circle, but still in the rectangle. When you get to a Venn diagram with 2 or more sets, you have to be more cautious. We will not go beyond 3 sets. We're not going to 3 sets today, but we'll focus on 2 sets. How do you draw a Venn diagram for 2 sets? Well, first off, let's take a look at our universal set and the sets contained within. Our universal set is still 1 through 10, and set A still contains 1, 2, 4, and 8. But set B contains 2, 4, 6, 8, and 10. How do you draw a Venn diagram for 2 sets? Well, you start the same way as before, with a rectangle representing the universe. Capital U that looks like a horseshoe on the outside to say universe. And then for each set we draw a circle. Now here's where you have to be careful. Sometimes the circles will overlap, and sometimes they won't. It's never wrong to draw them overlapping. It may be wrong to draw them non-overlapping, and you'll see why as we process each element in the universe as to where it belongs, starting with the number 1. The number 1, the first number in the universe, does belong to set A, which means it needs to be inside circle A. But the number 1 is not an element of set B, which means the number 1 needs to be outside of circle B. For reference purposes, I'm going to label these regions. Well, I don't want to call them 1, 2, 3, and 4 because we already have those numbers. Let's use Roman numerals. Roman numeral 1, Roman numeral 2, Roman numeral 3, and then the region outside both circles we'll call Roman numeral 4. And this will just be for reference purposes, so we can talk about portions of this Venn diagram. Now let's go back to the element 1, the number 1, which belonged to set A but not to set B. Which of the 4 regions should I put the 1 in? Region 1, region 2, region 3, or region 4? Well, because the element 1 belongs to A, it should be inside of circle A, but because it does not belong to B, it should not be inside of circle B. So which region is inside of A, but outside of B? Region 1. Number 1, you belong here. What about the number 2? The number 2 is an element of A, but it's also an element of B. So where should it go as I'm drawing black marks on my jeans? Well, if 2 belongs to A and belongs to B, then it should be in both circle A and B simultaneously. And which of these 4 regions belongs to both circles? Region 2, the overlap, if you will. It's going to get crowded there in that little football space. Next, element 3. 3 in the universe does not belong to A, does not belong to B, therefore does not belong to either of their circles. Which of the 4 regions should I write 3 in? The 4th region. I invite you to pause the video and see if you can figure out where to write the remaining 7 elements. 4, 5, 6, 7, 8, 9, and 10. Some of them will belong in region 1, which belongs to A but not B. Some will belong in region 2, which belongs to A and B. Some will belong to region 3, which belongs to B but not A. And then some will belong to region 4, which belongs to neither circle. So pause the video and see if you can fill in the rest of the numbers. At this point, you've either paused the video and attempted to locate the remaining elements of the universe in the Venn diagram, or you haven't. And if you haven't, my question is, why not? Now's a good chance to see if you get it before I tell you how to do it. It's easy to follow when I do it, but I'm trying to see if you can do it without me taking the lead. So if you didn't pause the video, I'll give you another chance. If you didn't do it the first time, I hope you did it this time. If not, then I don't know what else to tell you. Oh, yeah, I do. Let's figure out where the rest of the numbers go. The element 4 belongs to A, belongs to B, and therefore belongs to the region that is common to A and B, the football in the middle. It's going to get crowded. 4 goes in that little football region. The element 5 belongs to neither A nor B, and therefore must be outside of both A and B, it's in region 4. The number 6 is not an element of A, but is an element of B. Therefore must be outside of circle A, but at the same time inside of circle B, that would be region 3. Element 7 is in neither A nor B and lives outside of the 3 and 5. The element 8 belongs to both A and B, and therefore belongs to region 2. Getting full in there. The element 9 belongs to neither A nor B, and therefore goes in region 4. We'll put it over here just because. I could have put it anywhere as long as it was in neither circle. And then lastly, the element 10 does not belong to A, but does belong to B, which puts it in region 3, the region that is inside of B, but outside of A. So if you pause the video and attempted to fill in the Venn diagram, you were correct if the number 1 was the only number in region 1. In region 2, you had 2, 4, and 8. In region 3, you had 6 and 10. And then in region 4, outside of the circles, you had 3, 5, 7, and 9.